What's up, guys? It's your boy Justin, and welcome back to another cheat feature tutorial by a professional hacker for professional hackers only. This feature is called spot markers. It started off as a meme because I was joking around and I said this kid's cheat probably had a feature which showed him where all the one-ways are, and then I decided I would just actually add it to my hack. So, it's not too hard to add, but to give you a little preview of what it does, you can press a key on your keyboard or mouse, and it'll place down a little marker there wherever you are aiming at. And then if you want to remove it, you just hover over it and press the same keybind. And if they're visible, you can see you'll just stick a 3D sphere. And if they're not visible, like I said, the dot. Um, and then if you stand on it, you'll see it just shows that you're on top of it, basically. So pretty simple, not too hard to do. I guess the harder part would probably be like saving it and loading it based on the map and stuff, but it's really not that bad. So I just figured I'd show you how to use it 'cause it's kind of cool. And yeah, let's get started. Okay, so welcome to the coding segment of this video. Like I said, this is for pro hackers only. So if you're not a pro hacker, leave now. I'm gonna have some notes on my other screen, so I don't have to like think about all this stuff while I'm writing it. So if I move my cursor over there, that's why. But we're just going to create a header file called spotmarkers.h. I'm going to include my base here. And now we'll actually define the class. So C spot markers. Have a public. We're going to have a void called update. This is going to be called every time you update your visuals. So that's basically the main function for the cheat. And then we're going to have some private stuff. So we're going to have a void called refresh. This is going to be used to update your config files, essentially, or the positions, because obviously when we add or remove a position or we change maps, we want to update the ones that are in our game or the ones in the file based on that. So this is going to accept a level name as a string, otherwise known as a map name, but if you look in the engine interface, you'll see that it's called level name. And then you'll have a vector of vectors, and that's going to be called spots because that's basically just, all of the spots that we're going to be saving or loading. And that's by default, it's a vector, so it's by reference, so we don't need to worry about passing it as a reference or as a pointer. We're going to have a button down variable, a button clicked variable, so we can use those to check if they are clicking or if they have clicked the hotkey. And then we're going to have a string called level name, so we can log that somewhere and we can check if it changed. And we'll have the obviously most important parts, which is going to be spots, which is where we store the positions. Oops. And we're going to want to actually have a we're going to want to have an object for this later, so I'm just going to put that in here. I can't type today, bro. Holy shit. Alright. Let me create the CPP file. Alright, so let me get my notes open here. First thing we're gonna do is obviously include that file we just made. When I said I can't type today, I really wasn't joking. And we're going to obviously create an instance of that object. So C spot markers. What do we call it? Spot markers, I think. Oh, should be a pointer. Okay, so now we're just going to have some default values. If you're adding this to your cheat menu, obviously you're going to want to have these in the menu or something, but I'm just going to hard code them since this is just a tutorial on how to add the feature and how it works and all that stuff. So we're going to have color default, color close. This is basically the color that's going to be by default if you're not touching anything. This is going to be the color if you're on top of it, as you saw when I was in game previously. And then we're going to have the one for a selected spot or one that you're hovering over, basically. Now I'm going to write a function real quick that we're going to use later in the update function. This is going to be called distance meters. So I assume most bases probably have a function built in for this. That's just gonna take two vectors and get the distance between them in meters. But I'm just gonna write it real quick, so if you don't have the code, you'll have it. So I'm just gonna say dist is equal to the square root of the distance to squared from v1 to v2. So what this is basically saying is the v2 x position, y position, z position minus the v1 x, y, and z position. So basically the delta, you square each of those values, and then you get the square root of the sum. And then you would want to multiply this by the magic number. So that's going to be distance times 0.01905. And this will get you the value in meters. So that's one of those magic numbers. I have another one later when I'm doing the engine tracing, but I didn't actually reverse this or find it. So if you're curious where that comes from, go look at yourself. I don't really care that much. Now we'll start with our update function. Okay, so like I said, if you're adding this to your own sheet, you probably want to check if it's enabled or something. I'm not going to do that, but we're going to check if they press the key. So here we're going to write the code to see. We're going to try to detect if they clicked it, obviously based on information that we have, because this is going to be running constantly. So it's kind of, you can't just check if they're holding down the key. You need to check if they actually pressed it. So if they're currently holding down the key, G pressed keys is just an array of booleans for each key. So if this is true at this instant, that means the key is currently being held down. So if that key is being held down, we're going to set button clicked to false because they're still holding it. We're going to set button down to true because, like I said, they're holding it. If they're not pressing it, but it was being pressed, that means they clicked it. So if it was previously being pressed, but it's not currently being pressed, we know it was clicked. So we're just going to set button underscore clicked to true and button underscore down to false. Good. Oh, looks like I fucked up somewhere over here. I'm blatantly blind. I didn't write else if. Nice. Nice. Sick, bro. Okay. And otherwise we'll just set them both to false. Alright, so now we know if they clicked it or not. Regardless of whether or not they clicked it, we're going to actually go ahead and update the information based on the map. So let's just go ahead and get what the current map name is. So we're just going to call this old level name, and that's obviously going to be equal to the level name. Then we'll update the level name. So we're going to set it to the engine interface and get level name. So if the old level name is not equal to the new level name, then we know we need to update information. So obviously we're going to get it from a file somewhere. We're going to worry about that later in our refresh function, but I'm just going to write a little note there for now because we haven't written that yet. Let's make sure we have local player. Obviously we're going to need that. Let me just note, these globals might be different in your base. I assure you you'll have some alternative to it. Like you could just use get async key state for this, and you could use hack manager.plocal whatever for this, but you'll find it, you'll figure it out. Now over here we're gonna get the screen size and the center of the screen. So basically where your crosshair is, like speaking from a two-dimensional perspective, because we're gonna be using this for the selection later. So I'm just gonna write WH center X and I'm gonna write CX. Easy, bro. And then we'll use the engine get screen size, pass in the width and height. And now we obviously know that CX is W divided by 2 and CY is height divided by 2. I will also, just to make sure that we don't erase or select more than one spot at a time, keep those up there. Alright, so now we're gonna basically loop through every single spot we currently have, and we're going to either draw it or erase one, perhaps, or draw when it's selected. Basically change the color accordingly and then draw it. So to loop through them, just have index by default going to be 0. Then we'll loop while spots dots where I is less than spots dot size and increment. To get the current spot, which is a vector, we'll just do spots dot at I. And now we'll just set the color to whatever our default is, so default color, because we hard coded that earlier. And then we're going to, oh, I named it color default. And then we're going to want to get the distance in meters between our player and the spot. We're going to use that later. So I'm just going to say float distance 3D is equal to distance meters from our player's position. So we'll just do local player get origin and the spot. Alright, good. If the distance is less than or equal to 1, so basically if we're on top of it, we're just going to go ahead and set the color to the close. So we have that as the green. Now, here we're going to want to check if it's selected and then erase it if it is. This isn't too hard. Let's go ahead and convert the position to a two-dimensional point on our screen. So I should probably create a variable to put this in. We're just going to put spot in pos 2D. So if we're able to get that, we'll get the two-dimensional distance between our crosshair and the spot. So pos 2D dot distance, and this is going to be where your crosshair is, so the center of your screen. So basically CX, CY, and then obviously Z doesn't matter. So if the distance is less than a certain value, then we know our crosshair is really close to it, or close enough to it that we want it to be considered selected. So I'm just going to use 15 for this because I already tried it and it worked fine. And we want to make sure that we already haven't found a spot that is selected. So if that's true, we'll just set it to the selected color. And we will say spot found is true. So obviously we're only going to select one at a time. Now we're also only going to want to erase one at a time. So if they click the button while it's selected, so button underscore clicked, and we haven't already erased a spot previously, so spot erased, we're going to erase the spot. So that's obviously pretty easy. We're just going to do spots.erase, spots.begin plus I. Now we're going to say that we erased a spot already, so we know we don't have to erase another one. Also, this code that I'm writing right now is only going to be applicable if there are two spots really close to each other. Otherwise, it doesn't really matter that much. But better to have. And then we're going to obviously want to update. I'll put that note there because we know we erased a spot now. We're going to want to save that information to the file. So I'm just going to note that I have to do that later. Now we're going to want to actually draw the spot. So first I'm going to check if the spot is visible. So we're just going to do a little ray tracing here. So we'll have a trace ray struct. Call that ray. And then obviously a trace filter. Okay, so let's initialize the ray. That's going to be from probably our eye position to the 3D spot. So we'll do g local player get eye position to the spot. Now we're going to want to set that filter that we were talking about. So filter.pskip is going to be equal to our local player entity. And now we're going to do the actual engine tracing. So the engine trace interface we're going to trace array, and this accepts the array, and then this is the magic number I was talking about. For the mask, just put this number right here, 40x46004003 in hexadecimal format. And then obviously the filter, we just defined that, and the actual trace struct. Oops, I should probably pass those like this. Okay, so now we can check if it's visible or not. So we're just going to say bool is visible is equal to tr dot is visible. So the reason I did that is because we're obviously going to draw it accordingly. If it's visible, we want to draw that three-dimensional sphere, and if it's not, then we're going to want to do that little square that I was talking about, where it shows the meters that you are from it. So if it's visible, this is pretty easy. Obviously, we're just going to be, oh shit, we're just going to be using the debug overlay to draw that sphere. So draw, I don't even know what the function's called. What is it? Add sphere overlay. This is going to accept the position, so spot. And then for these values, the radius, theta, and whatever that is, I recommend you just use 7, 20, 20, and then obviously the colors, so C.R, C.G, and C.B. And for the alpha, I just used like 200. And the duration is going to be 0.025f, because that's going to be running constantly, so you don't really need to display it for that long. If it's not visible, we're going to draw that dot with the distance. So let's go ahead and get the distance in meters as a character array so that we can draw that. So we're going to use sprintf underscore s. So we're going to format this. It's going to be like that. And we're going to pass the actual distance, which we got somewhere up here, dist 3D. So now we have that. Let's go ahead and set the color to, why am I typing this? Draw set color. Set the color to C, and then we're going to draw our dots. So surface, draw fill direct. This accepts what? X0, Y0, X11. Okay, so I'm just going to make the size like, you know, it's going to be the 3 in each direction. So this is going to be the top left corner right here. So we'll do pos 2D dot x minus 3. So 3 to the left, and then 3 up. And now we're going to go 3 to the right, and 3 down. Okay, so we're drawing that. Now let's just draw the string slightly above where we drew that. So this is going to accept the font, so I'm just going to do the ESP font for my cheat. The X and Y positions, we're going to use the actual position so we can center this. Wait, let me actually move it up a little bit. It's going to be slightly above it, so I'm just going to do -7. This is going to be the color, so we're just going to draw it in white every time. Oops. And we have the alignment, so center that and pass the array. Okay, so that should all be good. As far as drawing goes, we have that covered. What is this? Is that my loop? Okay, that's my loop. Alright, so we're done looping through them all now. We've drawn everything based on the information that we have about it. So that's all good and fine. And now we need to actually check if we're going to add a spot wherever we're aiming at. So if they click the button, and we haven't erased a spot, because obviously we don't want to add a spot in the same position we just erased it like a millisecond ago. We're going to find out where the player's aiming, and we're gonna find where that collides with the wall. So we're gonna have trace starts. That's probably gonna be equal to our eye position, and then we're going to have wherever it ends, and we're going to have the 2D position. Actually, I don't even think I'm going to need the 2D position. Look at my notes real quick. Yeah, we're not going to use that here. I don't know why I have that. Alright, so first we're going to put our view angles. Yeah, okay, we're going to have to use our view angles here, so let me just log those. put those in view angles. Yes, and then we're going to take our view angles and put in trace end. All right, good. Okay, so we're gonna want to set trace start now. Obviously, like I said, we're just gonna start it at our eye position. Make sure you're using eye position, not eye angles. And we're gonna set trace end now. Like finally set it. So that's going to be trace start plus, and then whatever trace end is currently set to from angle vectors times. We have another little magic number here. 8192.0f. You'll see something similar to this effect if you are looking at like a trigger bot code in an internal cheat probably, and it's obviously going to check if you're colliding with a player. We're obviously not going to check for that because we want to find anything we collide with. So um, obviously same thing as earlier pretty much. We already have code for this here, so I'm just going to copy pasta. Now, what we need to change when we're initializing the array, we're going to want to draw it from trace start to trace end. We set the filter to local player, and then once again, we do the same code for tracing the ray. And now we just want to get the end position. So wherever that ray collides with something, that's where we want to draw our spot. So we're gonna get that as a vector. So I'm just gonna call it spot is the, I don't know what it's called, end pause, I think. End pause. And now we're gonna add that to our list. And we're gonna want to refresh the file now. So put in a note there. This is gonna be where we save it. So if we look back at that code from before, see we have a boolean called save. This is the only scenario where it's gonna be true. Actually, no, it's gonna be true here and here, and then if the map change, we're gonna load, so it's gonna be false. So that's the main chunk of the feature. Now to worry about actually saving these. This accepted all this stuff. Okay, so the first thing we're gonna do is remove those, because when you get the level name, it's gonna include like basically some path stuff, so it's gonna have like slashes in it. So we're gonna fix that up real quick. So I'm gonna just make a string called level name fixed. So we'll loop through all of the characters inside of the level name string. So level name.size. And for each one, we're basically just going to say if that character at this index is not equal to whatever we're ignoring. So we're going to ignore this backslash. Then we're going to set level name fixed. We're just going to append that character. So basically plus equals level name I. Alright, so that's good. Now we're going to have the path. We'll just do a static character array called path with max underscore path. Okay, good. And then we have to make strings for the folder and the file, because obviously we're going to adjust the file name based on the level. And then we're also going to use app data, so that's where it's going to be stored. This is for Penguin, so I'm just going to write it as I would. So folder and file, and then we're going to make sure that we succeed at getting the app data path. So if succeeded, oops, sh, I think it is get folder path, we are going to pass the, wait, no, we don't need anything for that actually. And then this is going to be csidl underscore app data. Okay, good. For the token, we don't need anything. We don't have any flags that we need, and we're just going to put that in path. Okay, good. So basically, if we succeed at getting the app data path and putting it in this this character array, then we're going to have scCMD256, and we're going to put this in there. We're going to put, basically, we're going to format a string with the level name. So we're going to put it in appdata slash penguware. I'm just going to call this folder spot markers. So we're going to have a folder in their configs folder, basically, where these are stored. And we will format it just like an SNI or an INI file. So whatever .ini, and then we'll pass in the fixed level name. Okay, I think that's going to be good. So let's go ahead and set our folder. So same concept there. We're just going to set it to get that character array, put in a path, and go ahead and encrypt this. Penguware spot markers. So that's going to be the folder that we're putting it in. And then obviously the file is just going to be equal to the, the path, same thing, plus szcmd, right? Yes, okay, good. Now if that folder doesn't exist, we want to create it, so create directory A, and that's going to give us a path name, so folder.cstring, and then we don't need actually any attributes there. And then also if the file already exists, if we're saving it, we're going to delete it. Wait. We're going to delete it anyway? No. We're only going to delete it if we're saving it, so I'm going to hold off on that. Alright, so if we're saving it, then we're going to go ahead and delete. Why am I writing it like that, dude? Delete file A. File name, so we're just going to pass file .cstring. And now we're going to want to find a way to save all of these vectors into a file. So this shouldn't be too hard. I'm gonna have a separate group for each one, and then I'm just gonna have an X, Y, and Z in each group. So the way I'm gonna do this is take a little loop here, a little for loop. Start I at 0, and then obviously while I is less than spots dot size, and we'll increment that. So basically for each item, we're gonna get that spot. So I'm just gonna call this spot. And now here's we get to the part where we want to save this. So we're going to use this function called write private profile string A. So this is going to be the section we're putting in. So I'm going to convert This is why I like C# way more than C++. because I don't like dealing with all these different data types. I'm one of those guys that just wishes everything was a string, bro. I'm a simple man. Okay, so this is if we want to load the file. So, similar concept here, but we don't know how many items there are going to be yet. So, the way that I thought of doing this is basically getting the X, Y, and Z position, and then if any of those, or rather all of those, are equal to 0, then we know, obviously, that there's nothing there, like it shouldn't exist. So, you would really never have a one-way or a spot marker at the origin of the map. If you wanted to, you could just use 0.1 instead of 0, but that's how I'm checking. So basically it'll keep going until it says that there's no more. So first off, we're gonna have somewhere to put this, put each item after we convert it from a string. We're gonna put it in a character array, and then we're gonna convert it to a float later, so I'll just put that there. We're gonna clear all the spots that we currently have. By default, we're gonna have I equals 0, and then we're gonna have a boolean called limit reached. That's gonna be false, and then we're gonna have a while loop that says while not limit reached. Here's what we're gonna do. So now instead of using write private profile string a, we're gonna use get private profile string a. Okay, so the app name, that's going to be the section. So basically, we're going to take that I value, convert it to a string. So std to string I, and then we're going to have our key name, which is just going to be x, y, and z. So x, the default. We have no default. We don't really need when we do a to f, like atof, whatever you want to call it. Basically a to f. It's going to set it to 0 if it can't find it anyway. And then for return string, we're just going to put in value, and then 32 is the size that we defined, and the file name is going to be file.cstring. Okay, so x is now going to be atof value. It's going to take value, whatever we just put inside of it, we're going to convert that to a float. We know that's the x position, so we're just going to do that 3 times. So this is going to be y, and then this is going to be z. So now we have x, y, and z, but if all 3 of those are equal to 0, we know that we've reached our limit, and we're just going to continue because we don't need to run this anymore. So when we type continue here, this is obviously just going to basically break the loop. Now we're going to set the spot to a vector with the x, y, and z positions. And we're going to add that into our list of spots and increment I. So that's pretty much all the code we're going to need. All we really have to do now is refresh it where necessary. So right here, we're going to call refresh with the level name, with spots, and we just added one, so we're going to want to save that. Right here, we're also going to want to save it. And right here, we're going to want to update it. So we're just going to write false there. So that should all be good now. In our visuals file, we're going to want to actually run the code. So let's get our spot markers.h, and then somewhere, where's my freestanding stuff? We'll just draw it right here. So we should have access to spot markers, and we're going to update. Let's compile this and then test it. Okay, so where did I have this? Let me open up the folder that I told it to save in real quick. Delete this folder. And we'll see if everything works okay. So created that directory. Now we're gonna put a spot here. We can see it works fine. It's detecting that we're getting close to it. So if we press it again, it gets erased. So I'm just gonna place one, and we're gonna look in here. We're gonna see that it actually did add the vector, place another one. We'll see there are 2 now. Obviously I could do this forever. There's no limit to how many can be inside of the file. Let's try removing one. We'll try to remove one at the first index to make sure it still works. And if we look, we'll see that it still works fine. And if you switch maps, the auto updating should all work good. Like we discussed before, where it's behind the wall, it's got the dot in the distance, that works fine. And if you're on top of it, you can see it changes to a green color. So that is how you make the feature. Like I said, I kind of made it as a meme. I'm just making a video on how to make it because it's not like it's ridiculously useful or anything. It doesn't put anyone at a significant advantage. And it's something cool that you can add to your paste if you want. So yeah, subscribe if you want more videos like this with neat features. And also like the video if you're cool. Bye.